Ever wondered what gives particles their mass? Enter the Higgs boson, the particle that holds the answer. Welcome to the fascinating world of particle physics, where we'll be exploring the enigmatic Higgs boson and its profound significance. Known as the building blocks of the universe, particles are at the heart of our understanding of the cosmos. Yet, there was a missing piece that puzzled scientists for decades. What gives these particles their mass? This is where the Higgs boson comes into play. It's not just another particle, it is the key to unlocking one of the universe's most profound secrets. Its existence was proposed to explain why particles have mass, a fundamental property that shapes the universe as we know it. You see, the universe isn't just a void filled with particles. It's a vast expanse permeated by fields, including the Higgs field. When particles move through this field, they interact with it, gaining their mass. The more they interact, the heavier they become. And the Higgs boson? It's a manifestation of this field, a ripple that proves its existence. This brings us to the standard model of particle physics, the theory that describes the fundamental forces and particles in the universe. It's a bit like a jigsaw puzzle, with each particle fitting into a specific place. The Higgs boson completes this puzzle, filling in a crucial gap that had been empty for far too long. While the Higgs boson is a relatively recent discovery, it was predicted over half a century ago by physicist Peter Higgs and others. Their groundbreaking work laid the foundation for one of the most exciting hunts in scientific history, leading to the eventual discovery of the Higgs boson at the Large Hadron Collider at CERN. So, the Higgs boson, a crucial piece in the puzzle of our universe, was predicted long before it was discovered. And its discovery has not only confirmed our understanding of the universe, but also opened up a new frontier of exploration in particle physics. The existence of the Higgs boson was predicted in 1964, but it took nearly 50 years to confirm its existence. This elusive particle, named after physicist Peter Higgs, was a missing piece in the puzzle of the standard model of particle physics. Higgs, along with several other scientists, proposed that all particles acquire their mass through interactions with an invisible field, now known as the Higgs field. And the Higgs boson is a manifestation of this field. For decades, this remained a theoretical proposition. Scientists needed a way to prove it, to observe the unobservable, so to speak. Enter the Large Hadron Collider, or LHC, the world's largest and most powerful particle accelerator, nestled deep beneath the Swiss-French border at CERN, the European Organization for Nuclear Research. The LHC was the game changer. It works like a gigantic microscope, accelerating particles to nearly the speed of light and smashing them together. These high-energy collisions create conditions similar to those just after the Big Bang, allowing us to study the fundamental building blocks of the universe. Now, finding the Higgs boson wasn't as simple as just looking through a microscope. When particles collide in the LHC, they create a flurry of other particles. Amidst this chaos, scientists were looking for a very specific pattern, a telltale signature of the Higgs boson. It was like finding a needle in a cosmic haystack. After analyzing data from billions of collisions, scientists finally observed the signature they were looking for. On July 4, 2012, CERN announced they had found a new particle consistent with the Higgs boson. Further analysis confirmed it. They had discovered the Higgs boson, the last missing piece of the standard model. The discovery of the Higgs boson was a monumental moment in the world of physics. It validated decades of theoretical work and provided a deeper understanding of why particles have mass. And in 2012, the world celebrated the discovery of the elusive God particle. This wasn't just a triumph for the scientists at CERN, but a victory for human curiosity and our relentless pursuit of knowledge. The discovery of the Higgs boson was a milestone, but why is it so important? The Higgs boson is the physical manifestation of the Higgs field, an invisible energy field that permeates the universe. This field is of paramount significance because it's the reason particles have mass. Now let's take a moment to wrap our minds around that. When you lift a book, when you feel the weight of your own body, you're experiencing the influence of the Higgs field. Particularly, particles gain mass by interacting with this field. The more a particle interacts with the Higgs field, the more mass it has. Conversely, particles that interact less have lesser mass, and those that don't interact at all, like photons, are massless. But what about the Higgs boson itself? Well, it's a bit of an oddball. It's the only known particle in the standard model of particle physics that interacts with its own field. This is why the Higgs boson has mass and why it's so difficult to detect. Now let's consider the broader implications of this. The Higgs field and the Higgs boson fundamentally influence the structure of the universe. They determine the properties of elementary particles, which in turn shape the nature of matter and energy. If the Higgs field didn't exist, particles wouldn't have mass, meaning atoms wouldn't form, and life as we know it wouldn't exist. And it doesn't stop there. The Higgs boson's interactions with other particles, its mass and its very existence, all have profound implications for our understanding of the universe. They challenge our theories, provoke new questions, and inspire us to delve deeper into the heart of matter. So, while it may be small, the Higgs boson plays a colossal role. It's not just a particle, it's a key that unlocks the door to understanding why matter has mass, why particles behave the way they do, and ultimately, why the universe is the way it is. The Higgs boson, thus, plays a vital role in our understanding of the universe. The discovery of the Higgs boson was a huge leap forward, but there are still many unanswered questions in particle physics. The standard model of particle physics, despite its profound insights into the universe's fundamental constituents, has its limitations. It doesn't account for gravity, for instance, that ever-pervasive force that keeps our feet on the ground and the planets in their orbits. Moreover, it leaves dark matter, that elusive substance making up roughly a quarter of our universe, in the shadows. These gaps in our understanding beckon us towards new horizons of knowledge, towards theories that can unify particle physics and gravity, towards a grand synthesis of the micro and macrocosmos. Research is ongoing, with scientists around the globe tirelessly probing the universe's deepest mysteries. Some are exploring string theory, which posits that at the most fundamental level, all particles are tiny, vibrating strings of energy. Others are delving into quantum gravity, seeking to reconcile the quantum world with Einstein's theory of general relativity. The experimental methods used to detect the Higgs boson at the Large Hadron Collider, or LHC, have been pivotal in this quest. The LHC smashes protons together at near light speeds, creating extreme conditions where new particles like the Higgs boson can briefly come into existence. By studying these fleeting moments, scientists can test their theories, refine their models, and inch ever closer to the truth. But it's not just about understanding the universe. The technological spin-offs from this research are astounding. The World Wide Web, for instance, was invented at CERN, the European research organization that hosts the LHC, to help physicists communicate their findings. Who knows what future innovations might spring from the quest to unravel the universe's deepest secrets? The journey of discovery in particle physics is far from over. The unanswered questions, the unsolved mysteries, they keep us pressing forward, keep us exploring, keep us learning. The Higgs boson was a milestone, a triumph, but it was also a stepping stone. A stepping stone towards a future where we understand not just the particles that make up the universe, but the universe itself. The Higgs boson is not just a scientific curiosity. It has practical implications and contributes to our understanding of the universe. Delving into the potential of the Higgs boson, it's pivotal to acknowledge the technological advancements fueled by its research. The Large Hadron Collider, the very instrument that confirmed the Higgs boson's existence, is a testament to this. This particle accelerator, the largest of its kind, has spurred advancements in superconducting magnet technology and computing. The data processing demands of the Higgs boson experiments have pushed forward the frontiers of distributed computing, leading to the birth of the World Wide Web. Yes, that's right. The internet as we know it today owes its existence to particle physics research. Furthermore, the Higgs boson has been recognized for its monumental significance. In 2013, the Nobel Prize in Physics was awarded to François Englert and Peter Higgs for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles. This mechanism was later confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments at CERN's Large Hadron Collider. Looking into the future, the potential practical applications of the Higgs boson are as fascinating as they are speculative. Could understanding the Higgs field lead to new ways of manipulating mass, or even gravity? Could it open the door to technologies that are currently the stuff of science fiction, like faster-than-light travel or teleportation? The answers remain elusive, but the questions are tantalizing. The Higgs boson's discovery has opened up a new frontier in our understanding of the universe. It's a door to the unknown, a beacon illuminating the path to further discovery. It has already changed our world, and its potential to shape the future is immense. Indeed, The discovery of the Higgs boson represents one of the most significant scientific advances of the 21st century.